So, good day everyone. I am Benil Arcilia together with Trisha and Abueg, JJ Arsena, John Andre Balanay, Iverson Cabus, John Benedict Custodio, Raymark Eustacio, Kim Aaron Pamilara, Justin Figueroa, Diana Lynn Manaloto, Alena Francesca Mojica, Maria Alisa Pablo, Alisa Curin Romanes, and Franco Zamora. Today, we will gonna discuss to you concrete and universal testing machine under construction materials and testing. So the following are the outline of topics. So under concrete, meron tayong 6 parts. First is introduction, which composed of its definition and history. Next is major composition of concrete. Next is properties, types, uses, and testing of concrete under ASTM standard. So next naman is universal testing machine. So meron tayong 3 parts. First is introduction, which also composed of definition and history. Next is parts and function of UTM. So let's begin with concrete. So first is, what is concrete? So concrete is an artificial stone-like mass. So composed siya ng mga binding materials, aggregates, water, and admixture. So yung strength and quality ng isang concrete ay depende sa mixing proportion ng mga composition na to. So dito makikita natin yung formula of concrete. So pinagsama-sama siya ng binding materials, which is yung cement or lime. Next naman is fine and coarse aggregate, water, and admixtures. Next naman nating i-discuss ay yung brief history ng concrete. So, noong 6,500 BC, dito naitala yung kauna-unahang concrete-like building. So, kinreate siya ng mga Bedouins na mga Arabs and desert nomads. So, makikita natin yung mga ganitong structures sa Syria and Jordan. So, actually, this year is magandang stage para mas ma-improve pa nila yung kanilang building techniques. So, next naman ay noong 3000 BC, Egyptian used mud mix with straw to create an adobe-like building materials. At the same time, gumagamit din sila ng mga gypsum and lime to bind adobe bricks together, which is yung mga gypsum na yon ay salt sulfate mineral na nakakatulong nga para mag-bind ng materials. And at the same years, yung China rin ay nag-i-improve na rin sa kanilang mga building techniques and gumagamit sila ng cement created with sticky rice. So in the next year naman, which is noong 700 BC, yung mga Bedouins, discover na nila yung cement that hardens under water and created kilns for producing mortar around this time. So, yung mga mortar na to ay ginagamit nila sa pagko-construct nila ng floor, houses, and other structures. And also, around this time, they began to tapping the concrete material and had understanding that the subtones wouldn't work as well if it is too saturated. So, nagkakaroon na sila dito ng idea about sa mga mixing proportions. So, noong taong 600 BC naman, yung mga Greeks naman, yung mga nakadiscover na mga natural substance that can create concrete when they mix it with lime. So, as time goes by, noong 200 BC, the Romans would create the most of the structure with loose rock and materials, cementing them together with mortar. So, kaya magaganda rin at matitibay yung mga structure nila that time. They also use cosmetic bricks in combination with their version of cement. And gumagamit din sila ng mga non-structural blocks. Kaya magaganda yung mga structure nila kasi mga concrete ay ginagamit nila as aesthetic product and para din dun sa design. And as development in concrete continues, noong 1440, the collapse of Roman Empire made the interest in concrete dormant until manuscript explaining the substance resurfaced. So, nagsimula dito yung mga chain reaction for discovery of new ways to make and use of concrete for centuries to come. So, mas nide-develop nila dito yung concrete at kung paano mapapatibay yung mga structures nila. So, noong 1793 naman, nakilala si John Smeaton by creating more efficient method of producing hydraulic lime. So, yung product niya na to ay nakatulong sa pagsiset ng cement, and the modernized production made it easier to make concrete and have it set quickly. So, by using hydraulic lime, mas napapadali yung settling time ng concrete at ng cement. Noong 1824 naman, kinilala rin dito si bricklayer Joseph Astlin dahil sa pag-invent niya ng Portland cement, which is itong Portland cement na to ay hanggang ngayon ay ginagamit natin sa construction. So, Astlin produced the cement by burning chalk and clay in a kiln. So, yung kiln na to ay yung furnace para mas maging powderized yung cement. And later, nag-decide siya na mag-add ng mga limestone to the clay to create a clinker. So, ano nga ba yung clinker? So, basically, itong clinker na to ay naging backbone ng production ng mga Portland cement. So, in the late 80s naman, individuals in Germany, France, and US were simultaneously developing steel-reinforced concrete. And yung mga steel-reinforced concrete na to ay ginagamit lang nila for industrial builds and hindi pa for residential buildings. So, today naman, nagkaroon na tayo ng mga standard formula for Portland cement. So, ang Portland cement talaga ay isa sa pinaka-importanting composition ng isang concrete. So, way back 1917 nga, yung American Society for Testing Materials or ASTM, kasama ng National Bureau of Standard, minake sure nila that yung standard formula ay nasusunod para na lang rin sa quality ng substance. Ngayon naman, dumako naman tayo sa major composition of concrete. So, sinabi ko kanina, dun sa formula na meron tayong four composition ng concrete. Meron tayong binding material, which is the cement. And meron tayong aggregates, which is yung coarse and fine aggregates, pwedeng gravel or sand. And next is admixtures, and lastly is water. Dito naman, malalaman natin ano nga ba yung mga function ng mga ingredients na to sa ating concrete. So, umpisahan naman natin to kay cement. So, ano nga ba si cement? So, cement is the hydraulic binder which is used to produce concrete. So, pag sinabi natin hydraulic, it means hardening when combined with water. So, nakakabuo tayo ng cement paste kapag yung cement natin ay minix natin sa water. And it sets and hardens by hydration both in air and underwater. So, the main base of this Portland cement are limestone, marl, and clay. And minimix sila at sinusunog sa kiln under 1,400 degrees Celsius to form clinker, and which is later ground to the well-known fineness of cement. Next naman ay aggregates. So, aggregates can occur naturally, pwedeng fluvial or glacial, industrially produced like lightweight aggregates as well as recycled aggregates. So, itong mga concrete aggregates na to ay kinokonsist ng sand and gravel. So, nire-represent nila yung grain skeleton of concrete. So, all cavities within this skeleton have to be filled with binder or binder paste as much as possible. So, yung mga concrete aggregates natin, sinasum up to approximate 80% of the concrete or concrete weight and 70% of the concrete volume. So, para sa mas magandang quality ng concrete, nililinis nila or ginigrade nila itong mga to, yung mga aggregates, by mechanical processes such as crushing, washing, screening, and mixing together. And under aggregates, meron tayong dalawa, which is coarse aggregates or gravel and fine aggregates or sand. So, ano nga bang function ng coarse aggregates sa ating concrete? So, number one, it makes a solid and hard mass of concrete with cement and sand. It provides bulk to the concrete. It increases the crushing strength of the concrete, and it reduces the cost of concrete by using cheaper materials. Yung sand naman, it assists in producing workability and uniformly in a mixture. Ina-assist din niya yung cement paste to hard the coarse aggregate particles. It also helps to prevent possible segregation of paste and coarse aggregate, particularly during the transport operation of concrete for the long distance. So, itong mga fine aggregates na to, nire-reduce din niya yung shrinkage of binding materials. Pine-prevent din nito yung mga pag-develop na mga cracks in the concrete. So, siya yung pumipigil doon sa mga cracks sa concrete. It also fills the voids existing in the coarse aggregate, thus it helps in the increasing the density of concrete. It also assists in hardening of cement by allowing the penetration of water through this void. So, with this sand, siya yung nag-fill out dun sa mga empty spaces natin sa concrete. So, para walang air, walang gaanong air. Third naman ay admixtures. So, itong mga admixtures na to are artificial or natural materials, pwedeng in a form of liquid or powders na ina-add natin sa cement, water, and aggregate para ma-improve yung property ng concrete during casting, setting, or sa service stage. So, itong mga admixtures na to, pwede silang fly ash, GGBS, RHA, silica fume, metakaolin, or POFA. So, ano nga ba yung function ng mga admixture na to sa ating concrete? So, number one is ini-improve nito yung workability of fresh concrete. Pati na rin yung durability by entrainment of air, at nire-reduce din niya yung water requirement sa concrete. Also, accelerate setting and hardening, and thus to produce high early strength. To aid curing, to impart water repellent or waterproofing property, and cause dispersion of cement particles when mixed with water, and to retard setting, so para mas madali ngang matuyo, and to improve wear resistance or yung hardness niya, to offset or reduce shrinkage during setting and hardening, to cause expansion of concrete and automatic pre-stressing of steel, para na rin produce ng lightweight product, para mag-impart ng color sa concrete, mag-offset or mag-reduce ng some chemical reaction, ma-reduce yung bleeding, and to reduce evolution of heat. Lastly naman is water. So, ano nga bang tulong talaga ng water since ito rin ay importante sa paggawa ng concrete. So, water is required with chemicals react with the cement. So, yun nga, katulad ng sinabi ko kanina, ginagamit natin si water para magkaroon tayo ng cement paste. Para pag inad natin si water kay cement, magkakaroon tayo ng binding materials. And also to supply workability with the concrete. So, the number of water within the combined in pounds compared with the number of cement is named the water cement quantitative relation. So, may ratio between the water content and yung amount ng cement. So, the lower the WC or water cement ratio, quantitative quantitative relation, the stronger the concrete. So, higher strength and less permeability. So, to discuss the properties of concrete, here is Justin Figueroa.
Good day, I am Justin E. Figueroa and I will be discussing the properties of concrete. The first one is strength. So may iba't ibang uri tayo ng strength. Merong compressive, tensile, flexural, and shear strength. Ang una is compressive strength. So ano nga ba ito? It is the ability of material or structure to carry the loads on its surface without any crack or deflection. So ang compressive strength ng concrete is usually at 15 to 30 MPa, pero nag-iiba pa rin siya sa mga commercial and industrial structures. So depende yun sa application. The compressive strength of concrete varies depending on the quality, proportion, and grade of the material used and the procedure of making. So ano ba yung compressive strength? So ito yung ability to resist axial loads, no? Yung papatong sa kanya. So yung kino-compress, yung mga loads na nagko-compress sa ating concrete. So nagba-vary daw yung strength ng ating concrete depende dun sa proportion. Halimbawa kung tama ba yung dami ng semento para dun sa dami ng aggregates at saka ng buhangin, saka dun sa water content. O kaya naman yung shapes, saka yung quality ng aggregates na ginamit natin. So yung mga ganong factors nakaka-apekto siya dun sa compressive strength ng concrete. Yung concrete usually reach the 99% of the target strength at 28 days. Pero depende pa yan dun sa uri ng semento na ginamit para dun sa concrete. The next one is tensile strength, the maximum load that a material can support without fracture when being stretched. It greatly affects the extent and size of cracking in structures. Concrete is very weak in tension due to its brittle nature. So, medyo mahina daw yung concrete, no? Kaya mapapansin natin, malimit may mga crack. Yun yung problema sa concrete, malimit may crack. No? Kasi mahina yung tensile strength niya, mahina siya sa tensile stress. Concrete's tensile strength is about 2 to 5 MPa lang. Unlike dun sa kanyang compressive strength na usually 15 to 30 MPa. So pag sinabi nating tensile strength, yung ability niya to resist tensile stress, which is yung mga pahila, no? Unlike dun sa compressive. The next one is the flexural strength. It is the ability of the material to withstand bending forces applied perpendicular to its longitudinal axis. It can be used to determine the resistance of a material against deformation. Flexural strength in ordinary concrete almost entirely depends on the tensile strength. No, so ito yung longitudinal axis ng ating concrete. So pag naglagay tayo dito ng pressure ng load, so ito nakakaranas to ng compression. But this one, nakakaranas siya ng tension. So mahina rin yung concrete natin sa tensile, di ba? So kaya dito siya nag-crack. Pero indirect na tension force yung ginamit na in-apply dito sa test sample na to, no? Flexural. So hindi rektang pahila. Flexural, gaya ng moments. Shear strength. It is the ability of material to resist forces that causes its internal structure to slide against itself. This is the real factor which determines the compressive strength of short columns. Concrete is especially weak in handling shear stress due to microscopic cracks in it. So, paano ba pag shear strength? Ganyan. Then, ganyan. Ano Halimbawa, ito yung sample natin, nag-break siya, no? Dahil nag-apply tayo ng force dito, then another one dito. So, mahina ang concrete sa ganang force, sa ganang uri ng stress, no? Napunit siya dito sa side na to. Ganon kapag shear. Kasi, bakit nagkakaroon ng ganon? Kasi merong microscopic cracks within concrete, hindi natin mai-eliminate yun. Property talaga yun ng concrete. So, ang concrete, pinakamaganda talaga siya sa compressive loads, no? Sa axial loads. Pero, hindi siya desirable para dun sa iba. Durability. It is the property which determines whether or not concrete can withstand the condition it was designed to endure without breaking down over number of years. So, ito yung katatagan ng ating structure. Halimbawa, dinesign natin yung structure natin for 50 years na magbubuhat ng ganitong certain load. But, within only 25 years, nasira siya. So, durability yung may dahilan nun, no? Durability is affected by internal and external factors such as environmental, physical, chemical, or mechanical. It is very vital as it affects the structure's lifespan. So, kagaya rin na sinabi ko kanina. So, yung environmental, physical, chemical, or mechanical factors naman, halimbawa, temperature, or acids, kung halimbawa, sa dagat nakasubmerge yung structure natin. Halimbawa, sa salt water, pero hindi natin na-consider. So, mas mabilis magde-deteriorate yung ating structure. Hihina yung durability niya, at pag humina yung durability niya, syempre, marereduce yung lifespan ng ating concrete. So, concrete is durable, low maintenance, and strong, but is greatly affected by other factors such as moisture. So, kagaya na sabi kanina, no, mayroong mga micropores, micro cracks within concrete. So, mabilis siyang mapasukan ng moisture, which is nakaka-apekto din sa mismong concrete natin. C. Elastic properties. It is the property of solid material to return to their original shape and size after forces deforming them have been removed. So, kagaya sa goma, no? Pag hinila natin, then pinakawalan natin, so babalik lang siya sa original form niya. Ganon din sa concrete. Yung concrete is considered as an elastic material when at the stage of planning. Kino-consider siya ng mga engineer as elastic material. Bakit? Kasi kapag maliliit yung stress, so elastic yung concrete. But habang tumataas yung stresses na inilalagay natin, humihina yung elastic property ng ating concrete. That's why there is no fixed value for the ratio between the stress and strain. So, tandaan natin na kino-consider siya na elastic material sa computation, but habang tumataas yung stresses na ilalagay natin sa kanya, sa concrete, so, bumababa yung elasticity niya, no? Which is possible na magresulta sa failure. Impermeability. It is the property of concrete that cannot be pervaded by water, oil, and other liquids with pressure. So, yung kakayahan na hindi mapasok ng liquid, no? A very important factor in order to control the penetration of liquids through the concrete, which can result to erosion of steel bars within the structure. Why? Because concrete is a porous material, which means that liquids can easily penetrate into it, which affects its durability, no? So, mapapansin natin yung mga bakal na kasama dun sa concrete, pinipinturahan pa yun ng special type of paint, anti-corrosive paint. Bakit? Kasi may mga micropores, porous yung ating material, yung concrete. So, mabilis siyang mapasok ng tubig. So, pag pumasok yung tubig at walang anti-corrosive paint yung ating bakal, kakalawangin yon, at kapag kinalawang yon, syempre mag-expand. Puputok yung concrete natin. So, hihina siya. Masisira siya. Yun yung Yun yung pumapasok dito sa impermeability. E. Segregation. It is the tendency of separation of coarse aggregate grains from the concrete mass. It is affected by the size and texture of aggregate and water content of the mixture. Can be minimized with proper handling, consolidation, and placing. So, paano ba ito nangyayari? Halimbawa, masyado matubig yung concrete natin, concrete mixture. Pag nabuo yun, syempre, magre-resulta yun sa honeycomb or ampaw. Pag ganun, naghihiwa-hiwalay siya, ayan, gaya dito. So, humihina yung overall strength ng ating structure dahil doon. Possible naman na masyadong malaki yung ginamit natin na aggregate kapag para doon sa application. So, magre-resulta rin siya sa ganito, segregation. So, tandaan yan, severe factor to. Masyadong malaki ang effect nito sa ating concrete. F. Bleeding. It is the tendency of water to rise to the surface of freshly laid concrete. It forms a scum layer popularly known as latans upon hardening. So, kapag yung concrete ay nagsisettle na, so tumataas yung mga water, no? So, dahil doon, minsan nadadala yung semento, humihina yung ating concrete pag nabuo na siya, no? So, ano pang resulta nito? Results in harder pouring of concrete mixture, especially at higher elevations, presence of microcracks, and making it more porous upon hardening. Normal lang naman na mag-bleed yung ating concrete, no? Pero kapag masyado na siyang mataas yung bleeding niya, so problematic siya, no? Para dun sa gumagawa. Fatigue. It is the weakening of a material by repeated loads with many cycles occurring over the life of the structure that leads to concrete fracture. It is the most common source behind failures of mechanical structures and leads to fracture, cracking, and eventual collapse or failure because the structure due to shear, tensile, or compressive failure. So, kahit na dinesign natin yung concrete natin na mag-handle ng higher loads, pero maliliit na loads lang siya, pero madami yung maliliit na loads na kalimitan in a cycle, no? So, every cycle magre-result yun sa, possible na mag-result yun sa microcracks, then maiipon yun, then over the years will result to higher cracks. At pag naipon ulit yun, possible na magkaroon tayo ng failure. Common to sa bridges, commercial structures, road, hospital, pavement, stadiums, and theaters. Can be prevented at the designing stage. So, halimbawa sa bridge, kahit na maganda yung design natin, so possible na masira pa rin siya dahil sa ganito. Hindi natin masasabi na substandard yung structure dahil nga dito sa fatigue. Hindi lang to sa concrete, kahit sa ibang material, ganun. So, pwede natin siyang ma-lessen sa designing stage. So, kaya mahalaga yung frequency. Kasi na i-consider natin, lalo na dun sa purpose mismo ng structure natin, no? Kasi dahil dito sa fatigue. And that's it. The next part will be discussed by Miss Diana Lynn Manaloto.
Next is workability. Workability is a property of raw or fresh concrete mixture. It describes the ability of the concrete mix to be placed within the formwork. The desired workability is not the same for all types of concrete. Hence, we can set a standard workability for all casting works. Kaya dapat na laging i-test ang concrete using concrete slump test tulad nung nasa photo. The concrete slump test is an on-the-spot test to determine the consistency ng concrete. This test plays a vital role in ensuring immediate concrete quality in a construction project. The following are the steps ng concrete slump test. Step 1. We need to make sure that the mold is clean para walang ibang factors ang makaapekto. Step 2. The mold is then placed sa base plate. The base plate should be also clean and non-absorbent. Step 3. The mold is filled with fresh concrete. Each layer is tamped 25 times with steel rod, and the tamping should be done uniformly to make sure na compacted yung concrete na nilagay. Step 4. After filling the mold, excess concrete should be removed and the surface should be leveled. And when the mold is filled with fresh concrete, Step 5. The mold is then lifted gently in the vertical direction and the unsupported concrete will slump. The decrease in height at the center point is measured to the nearest 5 mm or 0.25 inch and it is known as slump. There are three types of slump. These are true slump, yung una nasa picture. In a true slump, concrete just subsides shortly and more or less maintain the mold shape. This type of slump is most desirable. As you can see in the picture, mas bababa yung movement ng concrete. Shear slump. If one half of the cone slides down in an inclined plane, it is called a shear slump. Shear slump indicates lack of cohesion in the concrete mix and considered unsatisfactory. Collapse slump. In this case, fresh concrete collapses completely. Usually, mas mataas yung water content ratio sa slump na to. And here is the video.
The ease with which one can work with concrete is called workability. This can be measured using a simple test called the slump test. Let me show you the procedure. Slump cone test is a simple and popular test extensively used at sites to assess the workability of the concrete mix. The test should be conducted at the commencement of the concreting operations or whenever the workability of the concrete changes. The apparatus for conducting the slump test essentially consists of a metallic mold in the form of a frustum of a cone with a base plate. A steel tamping rod of 16 mm diameter and 60 cm height is to be used for compacting. The internal surface of the mold should be thoroughly cleaned of moisture and any hardened concrete before commencing the test. The mold is placed on a smooth, horizontal, rigid and non-absorbent surface. It is then filled in 4 layers with the thickness of each layer being approximately 1/4 of the height of the mold. Each layer should be tamped 25 times evenly using the rounded end of the tamping rod such that strokes are uniformly distributed over the cross-section. After the top layer is tamped, the concrete is leveled with a trowel so that the mold is filled exactly to the top. The mold is then removed by raising it gradually. The concrete will subside. This subsidence is known as slump. This operation shall be carried out without any jerks or vibrations and within a period of 2 minutes after completion of final tamping. The difference in level between the height of the mold and that of the highest point of the subsided concrete is measured. The subsidence measured is the slump of the concrete. The slump may either be a true slump, a shear slump, or a collapsible slump. The true slump is the desired form of slump that we require. In harsh mixes, the concrete slides down in an inclined plane. This is known as shear slump. In collapse slump, the concrete collapses as soon as the cone is removed. It usually occurs in very wet mixes. The concrete demonstrating a shear or collapse slump is considered unsatisfactory. In case of slump results beyond the specified limits, the mix proportion needs to be adjusted, especially the water content. The slump can also be varied by changing the proportion, size, and combination of the various sizes of the aggregates. It is advisable to assess the workability of concrete mix using a slump cone. Ensure that the cone is filled in a proper manner as indicated. Notice the type of slump. Shear and collapse slump are undesirable. Adjust the slump to the desired value by changing the proportion.
Next, let's discuss the factors affecting the workability of concrete. First, water content. To increase the workability of the concrete, certain amount of excess water is added. However, it should be noted that increasing the water content of concrete will have some effect on strength of the concrete. Kapag maliit ang water-cement ratio, pwedeng maging mas mataas yung strength ng concrete, but usually lumiliit yung workability nito. Next is mixed proportions. Aggregate cement ratio is also an important factor which influences the workability of the concrete. If the aggregate cement ratio is higher, the lean concrete is formed. In this case, less quantity of paste yung available for providing lubrication. Hence, workability is reduced. Whereas if the aggregate cement ratio is lower, rich mix is formed. In this case naman, more paste is available to provide lubrication. Hence, better workability of the concrete is observed. Next is size of aggregates. The bigger the size of the aggregate, the lesser is the surface area. Hence, less amount of water yung required to wet the surface. Thus, less space is required for lubricating the concrete surface to reduce internal friction. We can say na the bigger the size of aggregates will give higher workability. Shape of aggregate. Compared sa rounded or cubical shaped aggregates, the angular, elongated, or flaky aggregates will make the concrete very harsh. Thus, rounded aggregates will have better workability since rounded aggregates has reduced frictional resistance. This is due to the rounded aggregates having less surface area and less voids kaysa sa angular or flaky aggregates. Grading of aggregates. A well-graded aggregate has the least amount of voids in a given volume. Thus, when the total voids are less, an excess space is available to give better lubricating effect. With the excess amount of paste na to, the mixture becomes cohesive and fatty, which prevents segregation of particles. Thereby, the aggregate particles will slide past each other. Thus, the better the grading of aggregates, the lesser void content at mas high ang workability ng concrete na to. Surface texture of aggregates. The total surface area of roughly textured aggregate is more than the surface area of a smooth, rounded aggregates ng same volume. Thus, it can be inferred that roughly textured aggregate will sure poor workability, at yung smooth or glassy texture aggregate will give better workability. Use of admixtures. Admixtures are also used to improve workability. The plasticizers and superplasticizers greatly improve the workability of concrete. Use of air entraining agent reduces the internal friction naman between the particles. Similarly, ang paggamit ng fine glossy pozzolanic materials increase the surface area and offer better lubricating effects. Use of supplementary cementitious materials. There are many supplementary materials used for improving quality of fresh concrete. Some of these, like fly ash, improve workability, and some of these, like steel or synthetic fibers, decrease workability. Next is time. Fresh concrete stiffens with time and lost workability, though hindi siya exactly settling or getting strength at all. The loss in workability by time depends on Various factors like initial workability. Kapag mataas yung initial workability natin, slump loss will be greater. Property of cement. If alkali content is high and sulfate content is low, slump loss naman will be also greater. Moisture content of aggregate. Dry aggregate will absorb more water at dahil dito, magde-decrease yung workability. And last, temperature. High temperature reduces workability and increases slump loss. Pero kapag gumamit ng stiff mixes, hindi ito masyadong maapektuhan ng temperature kasi mas apektado ito ng water content. And to discuss the next topic, here is Alisa Pablo.
So now we are going to present the types of concrete as well as their compositions and their ASTM codes. I am Maria Eliza and Pablo, and I am going to discuss the first 9 types of concrete. First is the plain and ordinary concrete. This type of concrete is one of the most commonly used concrete in construction. This uses the common ratio of the mixed design, which is the 1:2:4 ratio with its component of cement, sand, and aggregates plus a specified quantity of water. When it comes to durability, plain and ordinary concrete can serve its purpose. It is often used in the construction of pavements and in buildings kung saan hindi required na mataas ang tensile strength. The ASTM code that can be applied with this type of concrete is the ASTM C150. The next type of concrete is the lightweight concrete. Any types of concrete having a density na mas mababa sa 1,920 kg per cubic meter is classified as lightweight concrete. It is called lightweight kasi ang mga aggregates na ginamit dito ay lightweight din, such as natural materials like pumice and scoria, artificial materials like expanded shales and clays, and processed materials like perlite and vermiculite. The most important thing to remember sa type ng concrete na ito ay low siya sa pag-conduct ng thermal heat, or kung ikukumpara siya sa plain and ordinary concrete kasi, ang plain and ordinary concrete meron silang thermal conductivity na 10 to 12, samantalang ang lightweight concrete only has 0.3 thermal conductivity. Common uses for this concrete type is for creating long-span bridge decks and building blocks. As for the advantage, dahil nga siya ay poor conductor, it is used to protect steel structures. ASTM code for this type of concrete is ASTM C330 number C330M-17A. So, next is the high density concrete. This type of concrete is also called as the heavyweight concrete. High-density concrete has a very specific purpose. It is frequently used in the construction of atomic power plants. Dahil sa mga heavyweight aggregates used in creation of high-density concrete, kaya niyang mag-resist ng radiation. The aggregates used for this type of concrete are high-density crushed rocks. ASTM code for this type of concrete is ASTM C637. So, ang next naman ay reinforced concrete na tinatawag din na reinforced cement concrete or RCC. This form of concrete is widely used in industry and modern construction. The strength of reinforced concrete is aided by placing wires, steel rods, or cables in the concrete before it sets. Ito ay yung kung tawagin ay rebar. Lately, people have used fibers to reinforce this concrete. As for today, aside from steels, yun nga, fibers na yung ginagamit na panglagay sa mga reinforced concrete. Ang dahilan kung bakit naglalagay ng reinforcement sa concrete is for the sole purpose of resisting compressive forces. Mas pinapatibay niya ang bond ng concrete elements, that's why yun nga, mas tumitibay siya. RCC is also considered as the most important concrete type. ASTM code for reinforced concrete is ASTM A1064/A1064M. So, ayun. Next is the precast concrete. This concrete is created and cast in a factory according to exact specifications. Precast concrete units are then transported to the site and assembled. This type of concrete can be concrete blocks, precast walls, or staircase units and poles. The advantage of using precast concrete is its speedy assembly. Since the units are manufactured in a factory, they are of very high quality. ASTM code for this type of concrete is ASTM C1227-20. So, ayan. Next is the pre-stressed concrete. Pre-stressed concrete is a special type of reinforced concrete. Many large concrete projects are pre-stressed concrete units. This type of concrete is created using a special technique. Kagaya sa reinforced concrete, meron itong mga bars or tendons, but these bars or tendons are stressed before sila ilagay sa concrete. Normally, ang mga pre-stressed units ay ginagawa at ina-assemble on site. Pre-stressed concrete is used to build bridges, heavy-loaded structures or roofs that have long spans. Pre-stressed concrete used high tensile strength steel and concrete of good quality. ASTM code for this type of concrete is ASTM A416/A416M-8. So, next is the air and train concrete. Some types of concrete hold billions of microscopic aerosols in 1 cubic foot. These tiny air pockets relieve the internal pressure on the concrete. They provide tiny chambers where water can expand when it freezes. So, yung air pocket sa concrete, nagkakamera ng ganun dahil sa mga nilalagay na mga foaming agents such as alcohols, resins, or fatty acids during the mixing process. So, this must be done under careful engineering supervision since the concrete is mixed on the job site. The amount of air entrained is usually about 3 to 4% of the total volume of the concrete. Almost all concrete used in a freezing environment or where there are freeze-thaw cycles is air entrained. This type of concrete is resistant to scaling, retardation, and abrasion. ASTM code for this type of concrete is ASTM C231 or kaya naman ASTM C173. So, next is the glass concrete. So, yung glass concrete, kinoconsider siya as modern form of concrete. Gumagamit siya ng recycled glass. So, pwede nating sabihin na eco-friendly ang glass concrete since it uses, recycled glass as ingredients. Ang glass concrete, ginagamit siya kapag kinakailangan ng aesthetic appeal sa design. Nakikita natin ito kalimitan sa mga slabs na ginagamit sa floorings ng mga pathways or kaya facade. This concrete can have a shining or colored glass embedded during the mixing process to give it a distinctive splash of color or sparkle. They provide better thermal insulation and also have a great appealing look as compared to other types. So, ASTM code for glass concrete is ASTM C1866/C1866M-20. So, next type is the rapid hardening concrete. This type of concrete is mostly used in underwater construction and in repairing of roads. Because its hardening time is very less, it can be hardened in just a few hours. They are also used in building construction, where the work should be done fast. ASTM code for this concrete is ASTM C150. So this is all for my presentation. To discuss the next types of concrete, here is Ray Marquis Tasio.
To continue, I am Remark Eustacio that will report the types of concrete. So, first is asphalt concrete. So, tinatawag rin siyang blacktop dahil nga sa kulay niya, kulay itim sa ibabaw. So, karaniwan natutuyo agad siya within 1 hour, kaya karaniwan ginagamit siya sa road, airport runways, and highways. So, it composed of dark minerals mixture of hydrocarbons called bitumen. So, combination rin siya ng aggregates and asphalt, kaya rin siya tinawag na asphalt concrete. So, with the ASTM code D4867 or D4867M. So, next is lime concrete, used for construction of floors, walls, and domes. Easily cleaned and is renewable. So, lime concrete din yung ginagamit natin nung wala pang cement na naimbento. So, it uses lime instead of cement, along with lightweight aggregates like glass fiber or sharp sand. So, with the ASTM code C141 or C141M. So, next is roller compacted concrete. So, strong and dense concrete used on heavily traffic highways with heavy loads, used as a filling materials. So, very less amount of cement is used. So, karaniwang concrete lang siya na ginagamitan ng road rollers. So with the ASTM code na C1800 or C1800M. So next is stamp concrete. So mostly used for architectural purposes. So yung nakikita natin minsang shape na hexagon, triangle, or kung ano man. So stamp concrete yung tawag doon, no? So, para siyang mga bricks na pinagdugtong-dugtong. So, for architectural purposes na maganda siyang tingnan. So, pigments are used for color purposes. So, pigments yung ginagamit niya kung gusto nyo mag-iba yung kulay niya. So, with ASTM code ASTM C979 or C979M. So, next is pump concrete, used for high-rise buildings where concrete conveyance other than the pump is not easy task. For more personal items like swimming pools. So, itong pump concrete, so gumagamit siya na ng PVC pipe, no? Na flexible or rigid para doon yung dadalo yung concrete natin. So, meron lang siyang nagpa-pump, no? Para makataas nga siya. So, it is made from rigid or flexible materials to discharge the concrete easily. So, yung PVC yung sinasabi dyan, parang PVC pipe. Or pwede rin namang hindi PVC pipe, basta rigid or flexible material siya. So, with the ASTM code C33. So, next is vacuum concrete. So, excess water is then removed from the concrete with the help of a vacuum pump. So, more quantity of water is added to the concrete mix, and then the mixture of poured into the formwork. So, yun nga, dinadagdagan natin ng mas maraming tubig siya bago natin siya ibuhos sa framework natin. Ngayon, yung mga sobrang tubig naman is ginagamitan natin ng vacuum pump para naman maalis yung excess na water at mas mabilis na matuyo. So, with the ASTM code na C1244. So, next is permeable concrete. So, used in those areas where stormwater issues persist. So, prepared in such a manner that the water can be passed on it. So, have about 15% void so that the water can pass in it. So, para nanilitin siyang stamp concrete, ang pinagkaiba lang is voids talaga yung mga nandun sa pagitan niya. So, about 15 to 20%, no? Voids yan para dun dumalo yung water natin at hindi maipon sa isang lugar. So, mapupunta siya sa drainage. So, with the ASTM code na C1701 or C1701M. So, next is shotcrete. Shotcrete concrete differs from other forms of concrete primarily in the way it is applied. So, hot through a nozzle onto a frame or formwork. So, pinagkaiba lang niya, no? Gumagamit siya ng air pressure, no? So, kung karaniwan ng ginagamit lang natin is parang shovel tapos ihahagis natin sa pader. Ngayon, gumagamit siya ng parang hose na with the air pressure para doon dumalo yung concrete natin. So same materials used in common concrete. So, fine aggregates naman siya, no? Para mas madali rin dumalo yung concrete dun sa host natin, no? So, para hindi hindi siya ma-stuck, no? So, with the ASTM code 1436. So, next is ready-mix concrete. So concrete prepared and built in a centrally located plant. So same materials used in common concrete. So pinagkaiba lang nito, no, bago siya makapunta doon sa mismong site. So meron siyang planta or lugar kung saan doon siya ihahalo doon sa truck na sinasabi. Tapos so meron siyang estimated time para makapunta doon sa site kung saan ibubuhos. So pagdating doon, ready na rin siya. So dapat naka ano siya doon sa estimated time kasi maaaring tumigas yun. So ASTM code niya is ASTM C94 or C94M. So to continue, here is Mr. Franco Zamora that will report the rest of the types of concrete. So thank you for listening.
Hi, I'm Frank Zamora and I'm here to continue the chapter 4, which is types of concrete. So for our S, we have self-consolidating concrete, or we also known as self-compacting concrete. So it is a high flowable and a non-segregating concrete. It is also a valuable when faced with difficult placement situations and aesthetic challenges. So itong self-consolidating concrete, sa mga building, lalo na sa mga structural element or design na mas lalo pa nagiging complex through time, nire-require talaga siyang gamitin kasi mas nagiging posible yung mga design na gustong gawin ng isang architect or ng isang civil engineer. So dahil nga sa ability niya na mag-flow easily, nababawasan niya yung manpower and equipment, which is good lalo na kung nagpapagawa ka ng isang bahay. Kasi nga makatipid ka dahil nga sa characteristic niya. And para sa ingredients and material use, we have cement, Portland cement, water cement ratio, aggregate, reinforcement, fly ash, and ground granulated blast furnace slag. At ang kanyang ASTM code ay ASTM C94. In T, fiber reinforced concrete or FRC, it is a high tensile strength and reduced cracking and it is a high tensile strength and reduced cracking are desirable or when conventional reinforcement can be placed. And it improves the impact strength of concrete, limits the crack growth, and leads to a greater strain capacity of the composite material. So dito naman sa fiber reinforced concrete, dahil nga sa fiber siya at maliliit lang siya na metal na ginamit, mas makatipid siya dahil compare mo dun sa mga bakal na talagang naka-reinforce sa isang concrete, mas malaki yung tinipid niya. And para naman sa strength, nga, kasabi nga dito sa definition, walang pinagkaiba yung strength niya sa strength niya sa common na mabakal talaga yung ginagamit. Dahil dito, nare-reduce pa nga niya yung crack at yung mga hair cracks na tinatawag. Next is fly ash concrete. It is a fine powder that is a byproduct of burning pulverized coal in electric generation power plants. It is a kind of pozzolan, a substance that containing aluminous and siliceous material that forms cement in the presence of water. So, itong fly ash ay isa sa mga common na ginagamit lalo na sa Portland cement concrete or Portland cement concrete pavement or tinatawag na PCC pavement. Kadalasan ginagamit ito sa mga road construction projects dahil nga ideal din siya lalo sa list ng mga types of concrete. Tsaka nirecognize na rin ito ng Federal Highway Administration. And bukod dun sa pagiging ideal niya, nakakatulong din to sa environment and even sa economic dahil mas nakakatipid ka Kasi nga dahil nga sa or produkto nga siya ng isang burning pulverized coal na galing sa electric generation power plants. At ang mga ingredients at materials na ginamit sa kanya ay prime material in many cement-based products such as poured concrete, concrete block, and brick. At ang kanyang ASTM code ay ASTM C618 to 19. High strength concrete. It is made by lowering the water cement ratio to 0.35 or lower. It is also a technological breakthrough in the building of columns, beams, and shear walls. So basically, itong high strength concrete, 2 or 3 times na mas matibay siya kaysa sa ordinary. At pagdating naman sa costing, mas makakatipid ka dahil instead na bakal, mas mag-focus ka sa graba. Kaya mas malaki yung advantage mo lalo sa economical side. At ingredients and material: Portland cement, super plasticizers, silica fume, fly ash, and slag. At ang kanyang ASTM code ay ASTM C387 or C387M217. Next is silica fume concrete. It is available in wet or dry forms and it is a very reactive pozzolan. It is also a highly pozzolanic material that is used to enhance mechanical and durability properties of concrete. Silica fume is byproduct siya ng ferrosilicon industry, kung saan yun nga na highly pozzolanic materials. Sa United States, ang silica fume ay ginagamit para mag-produce ng greater resistance to chloride penetration, lalo sa application tulad ng structure sa parking, bridges, and bridge decks. At ang kanyang ASTM code ay ASTM C1240. So, next ay polymer concrete. It is a concrete that is a composite material in which the aggregate is bound together in a matrix with a polymer binder. Composites possess a unique combination of properties dependent on the formulation. So, itong polymer concrete ay same lang siya sa ordinary na concrete. Pero, ang pinagkaiba lang nila ay sa ordinary, ang ginagamit is hydraulic binder. Hindi to sa polymer concrete, syempre, polymer material ang ginagamit. And itong polymer concrete, ginagamit siya kadalasan sa mga sahig, lalo sa kadalasang basa. Yun, dun siya lagi kasi mas na-absorb niya yung tubig compared dun sa ordinary. And then, in one day, ang strength ng isang polymer concrete ay maabot ng 70 to 75%. Kaso, ang kaibahan lang talaga nito sa ordinary concrete, mas mahal siya. Yun, mas mataas lang ang kanyang value kasi nga iba rin yung kanyang quality. And then para sa ingredients and materials used, it is composed of aggregates that include silica, quartz, granite, limestone, and other high-quality material. At ang kanyang ASTM code ay ASTM C579. And why is ferro cement concrete? It is a highly versatile form of reinforced concrete. It is also a type of thin reinforced concrete construction in which large amount of small diameter wire meshes uniformly throughout the section. Mesh may be metal or suitable material. So itong cement concrete ay inimbento ni P.L. Nervi, isang Italian architect noong 1940. So ang cement concrete ay nakakatulong lalo na sa mga design na complex, since yun nga, pwede siyang gamitin pwede kasing gamitin mo yung method na gunneting method, wherein para siyang ini-spray lang sa sa dun, kung ano yung surface na gusto mo, i-spray mo lang siya. And then, magiging possible na yung gusto mong mangyari. At ang kinagandahan nito, hindi mo na kailangan ng skilled worker. At hindi na masyado kailangan ng framework since sa kanya na mismo siya eh. May mesh na siya. Ayun na yung may silbing framework mo. At ang kanyang ingredients and materials used ay Portland cement, sand, water, and admixture. So, ang STM code ay ASTM C33286. And last, para sa types of concrete, we have pre-packed concrete. It is placed into stages where the coarse aggregates are placed inside the formworks, and then the grout is pumped from the underneath through a manual pump. It is also made by forcing into the voids of a mass of clean, graded coarse aggregate densely pre-packed in formwork. So, ang pre-packed concrete ay kadalasan ginagamit sa underwater. Ginagamit din to sa pag-place ng conventional concrete, lalo na kapag mahirap siya na gawin. And nagawa rin to for repairs and for reinforcement ng mga structures. And ang kanyang ingredients at materials used ay coarse aggregates, fine aggregates, cement, and dry admixtures. Ang kanyang ASTM code ay ASTM C387 and C387M. And to discuss the chapter 5, which is uses of concrete, we have Benedict Custodio.
So thank you. So the next topic of concrete and universal testing machines is the uses of concrete. So concrete, it is the most important building product. So compared to other materials such as wood and stone, so pinaka the best talagang gamitin ay yung concrete. So it is effective for underground use. So yung mga tunnel natin kadalasan tulad do sa picture, gawa siya sa concrete. Yung mga sewage natin gawa din sila sa concrete. So sustainable choice for residential and commercial projects. So in the present era or in the present time, kadalasan na ng mga ginagamit natin ay concrete, made of concrete. So its strength increases over time. So tulad ng stone, yung concrete natin medyo yung strength niya nag-i-increase over time, pero unlike stone, ang concrete natin ay may limit. Kumbaga hindi siya kasing resistant ng stone, lalo na sa tensile stress. It can hold up against weather conditions and is easy to maintain. So itong anong to, parang kino-compare yung concrete sa wood. So kapag nga minsan umuulan, umaaraw, ganyan, pabago-bagong weather, yung wood natin, madali siyang madecay or nagkakaroon siya ng mga fungus at madali itong masisira. So unlike concrete, kahit umulan, bumagyo, lumindol, nandyan pa rin siya. So it is budget friendly, easy to use and repair. So yun nga, tulad ng mga nabanggit kanina, easy to use and easy to repair. Safe for building occupants. So safe siya in form of, kung i-compare natin siya sa wood, 'di ba yung wood minsan nagkakaroon nga ng mga termites, tapos prone siya sa pest. Kaya kung gagamitin natin to as a material sa isa nating building, residential man siya or commercial project, yung occupants natin ay medyo magkakaroon sila ng problema. Unlike concrete na hindi siya prone sa mga ganong instances. So safe siya for building occupants. It is an inherent material which doesn't burn, mildew, or feed rot. Yun, tulad nga na sabi ko, di ba, yung kino-compare talaga siya sa wood. Parang pinaka kino-compare siya sa wood. Kasi yung wood nga, pag ginamit natin siya, kadalasan nabubulok siya or nagkakaroon ng fungus. Yung mildew, ano siya, isa siyang uri ng fungus, yung mga parang namumuti yung ating kahoy. Ganon yung itsura ng mildew. Tapos, yun nga, madaling masunog ang kahoy kung depende pala sa kahoy. Minsan kasi meron tayong inaano yung fireproofing. Pero at the same time, nasusunog pa rin talaga siya kasi nga kahoy siya. Its superior structural integrity provides added degree of protection from the severe weather as well as earthquake. So tulad nga nung binanggit kanina, concrete daw ay nakaka-hold against weather. Nagpo-provide siya ng added degree of protection. So sino ba naman ang may gusto na magkaroon ng bahay, tas nandun ka sa bahay, tapos feel mo hindi ka pa rin safe sa loob ng bahay niyo. So yun. So pag gumamit tayo ng concrete, nadadagdagan yung degree of protection natin sa mga iba't ibang natural calamities. It makes a home a quiet and relaxing place. So ayon daw sa study, yung paggamit natin ng concrete tsaka ng mga natural elements natin sa bahay, nakakadagdag daw ito sa sa parang relaxation ng ating utak. May nabasa akong ganun eh. So next, concrete is made locally and provides high level of durability. So dito sa atin, kadalasan kinukuha siya sa quarrying site. Produce locally talaga yung ibang concrete natin dito. Used as aggregate in road beds or as a angular materials while making new concrete. So pwede daw maging aggregates yung ating mga concrete, yung mga dinurog-durog, pwede daw natin siyang gamitin as aggregates sa road beds. It is fire resistant and good choice for sealing in storage area. So, pwedeng gamitin natin siyang sealing sa ating mga storage area. Kasi unang-una, kapag ka nag-i-store tayo ng mga chemicals, pag nasunog siya, parang dun lang sa storage area, hindi nakakalat yung apoy dahil nga made of concrete. So, it can be shaped in various forms when freshly mixed. So, di ba kadalasan nga ang concrete pwede siyang i-deliver through mixer truck or pwedeng doon na mismo sa site maghalo. And dahil doon, parang mas nagiging reliable siya compared doon sa other materials nga natin tulad ng wood, tsaka tulad ng stone. Kasi yung stone, alam naman natin, laborious talaga pagka i-resize natin siya. Tapos yung wood naman, kadalasan naman, pag bibilhin natin siya, yung isang haba na lang siya. Ganon. Kumbaga meron siyang uniform size pag binili. So it is not sensitive to moisture. So itong it is not sensitive to moisture, parang kino-compare siya sa wood and stone. Kasi minsan yung makikita natin sa mga stone structures, 'di ba, pag nasa labas siya, tapos medyo lumalamig, kita natin parang nagkakaroon siya ng mga tubig-tubig. And ganun din sa wood. Pero sa concrete naman, ang alam ko, merong ibang mga mixture na ngayon ng concrete na kung saan na siya, yung moisture yung hindi siya nagbo-moist, parang ganun. So doesn't release any volatile organic compounds into the air, which is environment friendly. So yun nga, pagka yung mga wood natin ay nagkakaroon na siya ng mga fungus, yung parang nabubulok na siya, parang nagre-release siya ng mga microfibers ganun sa hangin na kung saan minsan nagkokos siya ng allergy. Or minsan yung pagka inaanay siya, may nalalaglag na parang mga butil-butil yung kahoy. Nakakita na ba kayo ng ganun? And if so, yon I hope na i-imagine nyo yung sinasabi ko. May nalalaglag siyang mga parang butil-butil from wood, and sometimes masama siya pagka na sama sa hangin yon. So concrete gives longer service life. So tulad ng mga stone structures nga natin, doon din-design yung concrete natin eh. Kasi yung mga ancient civilization, yung mga stone structures natin, tumatagal siya ng 100 of years. Ano ba yung pinakamatagal nating stone structures dito? Yung mga pyramid natin, made of stones, limestones, I believe, yung ginamit doon. Tumatagal siya for hundreds of years. And yun nga, through modernization, para mabawasan yung labor cost natin, na-invento itong concrete or cement na ginagamit natin. So next, keeps the home safe from insect, doesn't attract insects, pests, and rodents. So yun nga, 'di ba, pagka wood ang ginamit natin, nakaka-attract siya ng mga insekto. Nakaka-attract siya ng mga anay, yung mga minsan langgam, 'di ba? And dahil doon, parang mas best yung concrete gamitin talaga. So it has multiple design possibilities. So yun nga, kasi yung concrete natin, namomold natin siya or nare-reshape natin siya sa kung ano mang gusto nating shape, kaya mas maraming design possibilities unlike wood, stone na masyado matagal bago natin siya ma-reshape. Yun lamang. So here is a video about the use of concrete.
Stonehenge in England. The Great Pyramid of Giza. The Peruvian citadel at Machu Picchu. These three are some of the wondrous examples of how stone structures can last hundreds, or even thousands of years. But though stone is one of the oldest and most durable building materials, it isn't exactly easy to work with. It's heavy, hard to transport, and usually comes in giant chunks, which have to be laboriously cut to shape. But wouldn't it be great if there were a recipe for stone, a kind of gooey cake mixture we could throw together wherever it was needed, simply pressing it into molds to make buildings and structures of any shape or size? Well, that kind of stone recipe really does exist. We call it concrete. Although it sometimes gets a bad press, because many people associate it with brutal urban architecture from the mid-20th century, concrete is the great, unsung hero of the modern, material world. But now you may think, why concrete is such a popular building material? From the Hoover Dam to the Sydney Opera House, you'll find it in the world's tallest skyscrapers, biggest bridges, longest highways, deepest tunnels, and quite probably even under the floor in your own humble little home. In cities, at least, concrete is everywhere you look, and it's not hard to understand why. It's easy to make from cheap and readily available ingredients, easy to pour into molds, and make into all kinds of shapes, and it's both fireproof and, relatively, waterproof. But the main reason it's so widely used in buildings is that it's extremely strong in compression. You can squeeze it or stand a great deal of weight on it. It's widely used in walls and foundations, the vertical supports, in other words, because it's great in compression. Unfortunately, concrete's very big drawback is that it's about 10 times weaker in tension than in compression. It cracks or snaps easily if you bend or stretch it, unless you reinforce it with steel. Although concrete looks heavy and monolithic, but it's actually much lighter than you might suppose. It's about a fifth as dense as lead, a third as dense as steel, 10% less dense than aluminum, and only fractionally more dense than glass. Although concrete is often mixed on-site and formed into whatever shapes are needed at the time, but it can also be supplied in precast modules, blocks, beams, wall sections, pavements, and cladding can all be made this way. Giant, modern segmental bridges, for example, are often quickly and inexpensively assembled from identical concrete sections that have been precast in a factory and shipped to their final location. That makes them quicker and easier to construct than if the entire bridge had to be cast in situ, which is much harder to do in the middle of a river or in adverse weather conditions. Another good option is to make concrete structures that combine some precast sections with other sections formed on-site.
That's all. Sana may natutunan tayo kasi maraming information tayo makukuha from the video, kaya pinili ko siya. So to continue the other uses of concrete, here is Mr. Iverson Cabus.
Okay, other uses of concrete in construction. This topic that I'm about to discuss are just some examples of other uses of concrete in different construction and different places. First, we have concrete dams. The characteristics of concrete, such as high strength and unit weight, make it a more suitable material for the construction of dams. Dams are used to store and produce electricity. Tama. The loads imposed on the dam due to water pressure are very intense, which makes concrete as a suitable material for dam construction. So, ano nga ba yung dam? Concrete dam is a structure designed and built for the purpose of holding back water, gaya ng nakikita natin sa picture, that is usually placed across the path of a river, malapit sa river. And dams are built for a variety of reasons, including flood control, yung pagpigil natin sa mga baha, at gaya na nasabi sa phrase kanina ay yung power generation and water management. A concrete dam is the strongest type of dam built in modern times and may take several forms. Concrete itself is a building material made from water, cement, sand, and gravel or aggregates. So, bakit tayo gumagamit ng concrete para sa dams? Dahil si concrete ay isa siyang excellent material for constructing dams because kaya niyang i-sustain kahit nasa matinding under compression, or ano ba yung compression? Yun yung press down, di ba? Pinag-aaralan natin. Or yung push together na dahil doon sa water, sa pressure ng water. Many designs for concrete dams take advantage of this property to produce extremely large dams capable of holding back many cubic miles. So, yung mga malalaking dams, ay mga extremely large dams, kaya niya mag-hold ng cubic kilometers napakaraming cubic kilometers ng water. So next, residential buildings. The construction of small buildings, villas, and even high-rise buildings are done using concrete with traditional or modern formwork as a method of construction of the skeleton from foundations to the slabs and of course columns and beams. Bakit tayo gumagamit ng concrete sa mga residential buildings? Siyempre gagamit tayo ng steel. Ano ilalagay natin anong isusupport natin dun sa steel? Siyempre kailangan natin ng concrete sa mga residential buildings. Bakit? Kasi concrete is so integral to our communities because it is the only building material that cost effectively delivers the lowest carbon footprints, yung mga greenhouse gases. Unlike yung cement, di ba, pag naggagawa ng semento, napakalaking inu-emit ng mga greenhouse gases. Although gumagamit tayo ng cement sa ating concrete, hindi naman puro cement lang ang ginagamit natin. Part lang ng concrete yung cement, which is magiging lowest carbon footprint for a structure or pavement over its life cycle. Next is number 3. We have commercial buildings. The use of concrete in commercial buildings makes it safer than using most other construction materials. It is mostly more economic than steel buildings and requires less maintenance. It is easy to control the heat transfer from inside to outside and vice versa, which reduces the energy consumed. Bakit tayo gumagamit ng concrete? sa ating mga commercial buildings. Ayan ang sabi, mas safer daw siya kaysa sa ibang construction materials. Gaya ng alin? Yung sinabi na steel buildings. At yung mga steel buildings na kailangan ng mas malaking pera pag gagawa ng maintenance. And nasabi na yung concrete piniprevent niya yung heat transfer from outside the building papuntang loob or inside the building papunta sa labas. Bakit? Kasi ang concrete na parang napipigilan niya yung heat transfer na napag-aralan natin sa thermodynamics. Next, we have marine construction. Concrete has bakit yellow? Okay. Concrete has had extensive use as a construction material for seawalls, jetties, groins, breakwaters, bulkheads, and other structures exposed to seawater. From marine construction, next po tayo sa next we have culverts and sewers or sewers. Sewers and underground construction works need strong and durable building materials, and concrete is the ideal one. Culverts, piers, foundation, abutments are constructed using special concrete mix. Ayan, kung hindi natin alam kung ano yung sewers at culverts, ayan, makikita natin sa babang image. Siya yung ginagamit na parang tunnel, which is hindi siya tunnel. Daanan siya ng water or para siya nagiging canal na ginagamitan din natin ng concrete, which is sabi constructed siya using special concrete mix. Ano po yung special concrete mix? Ito po ay madidiscuss natin sa mga susunod na reporters. And next, we have foundations. Ang pinakakilalang ginagamitan ng concrete, syempre yung foundations. The foundation of high-rise sa matataas na buildings, or low-rise is usually constructed using reinforced cement concrete, as it is durable and has a huge load carrying capacity. Ayan, kung makikita natin sa image na nilagay namin, yung foundations, hindi lang siya basta concrete. Syempre yung concrete, diba, may water, may cement, may sand, may aggregates, may gravel. Hindi rin mawawala yung reinforced steel o yung nilalagay natin ng mga bars. Bakit? Yung concrete ang nagsusupport dun sa steel na yun, which is commonly used sa mga foundations. 7. Fences. The development in the precast concrete industry has improved the industry of concrete fences. It is faster to produce and install the fence elements using precast than the traditional method of concrete fence construction. Moreover, it is beautiful and more attractive. Ayan, ang ginamit namin na image, which nagre-represent ng concrete na ginagamit natin sa mga fences. Ayan, una, yung fences natin, syempre may mga post yan, or pwede namang wala. Basta ang ginagamit lang natin para sa mga matitibay na fences or yung mga bakod ay concrete. Next, we have concrete bridges. Reinforced concrete strength, durability, ductility, weather resistance, fire resistance, and long-lasting life cycle makes the concrete the best solution for constructing the bridges. Pre-stressed concrete or post-stressed concrete, self-compacted concrete are different types of concrete that may apply in bridges construction. Pre-stressed concrete. Pre-stressed concrete, yun po yung mga concrete na hindi pa na a-applyan ng stress or ng mga loads. Post-stress concrete, vice versa, yun na yung mga na-applyan ng loads. And self-compacted concrete are different types of concrete that may apply in mga bridges construction, gaya nyo nasa picture. And to discuss testing of concrete, here is John Andre Balanay.
I am John Andre Balanay, and I am here to discuss the topic testing of concrete with regards to ASTM standards. So first, let us tackle the requirements of concrete. Requirements of good concrete mix. Number 1. The concrete should be mixed thoroughly to form a homogeneous mix. So when we say that the concrete should be mixed thoroughly to form a homogeneous mix, it says that all the ingredients or materials should be combined properly so that the composition will be uniform all throughout the mixture. Number 2. Concrete should be compacted properly to prevent it from being porous. So when we say porous, it means that the concrete has holes inside it, and those holes were occupied by gases, and those gases will lessen the strength of the concrete, and that is what we want to avoid. Number 3. Sufficient curing of concrete is required for developing full strength. So, curing of concrete is defined as providing adequate moisture, temperature, and time to allow the concrete to reach our desired properties. So, ibig sabihin nito, kapag minimix natin yung concrete, dapat nag-observe din tayo. Kung na-reach na ba neto yung desired natin na moisture at temperature. Tapos, mag-aalat din tayo ng time para dun sa concrete na i-absorb niya yung water na dinadagdag natin. Number 4. The water-cement ratio should be appropriate, considering the strength and workability criteria. So, ang sinasabi lamang dito sa number 4 ay dapat yung proportion ng amount ng water sa amount ng cement sa concrete mix ay dapat tama. Tapos, para malaman natin kung tama yon, dapat nagbe-base tayo dun sa desired strength ng concrete. Kasi sa bawat strength ng concrete, mayroon niyang required cement ratio. So mamaya may papanoorin tayong video dito kung paano naman i-compute yung water cement ratio. Number 5. The concrete mix should be designed properly and should have all the ingredients in right proportions. Sabi dito, kailangan maging maingat tayo sa pagdadagdag at pagbabawas ng mga ingredients. Kasi kapag hindi na natin ito natansya ng tama at lumabag na ito sa lahat ng ratio, maaari yung concrete mix natin ay hindi na pumasa sa kahit ano pang ASTM standards. So, number 6. The water used for mixing should be free from all harmful organic substances. So, to avoid unwanted chemical reactions, we should check the materials present in the water. So, dapat daw, tinitignan pa rin natin yung water na ihahalo natin sa concrete. Dapat wala itong mga unwanted materials. Kasi maaari itong magbunga ng chemical reaction na maaaring magpasama sa strength ng concrete. Number 7. The aggregate should be hard, durable, and properly graded. For most RCC works, 20mm size of aggregate is suitable. So first, i-define muna natin ano ba ang RCC. Pag sinabing RCC, ito ay tumutukoy sa Reinforced Cement Concrete. So yung Reinforced Cement Concrete ay concrete lang din siya na mayroong steel sa loob. Tapos yung RCC, kadalasan siyang ginagamit sa mga structure na kinakailangan na mataas na resistance sa bending moment. Kasi nga may steel siya sa loob. Kapag wala siyang steel sa loob, tas na-expose siya sa bending moments, yung structure ay magkakaroon ng cracks. So, yun. At dito sa number 7, sinasabi lang yung kung ano dapat yung aggregates na gagamitin natin para sa RCC. Number 8. The cement used for RCC works should be of good quality and measured by weight only and not by volume. So dito sa number 8, sinasabi lang dito yung standards para naman doon sa cement na gagamitin sa RCC works. Dapat daw good quality at measured by weight only, not by volume. Kasi, di ba napag-aralan na natin na yung particles ng cement, mayroon niyang gaps sa pagitan niya. Ayun, yung gaps na yon, mayroon yung air. Tapos yung air nag-occupy ng space. So kapag mineasure natin yung cement by volume, may isasama natin sa bilang yung space na inoccupy ng air. Hindi tulad sa kapag mineasure natin siya sa weight only. Kasi yung air na yon wala yung weight o kung meron man napakababa lang. So kapag tinimbang natin yung cement, mas makukuha natin yung desired amount natin. Dumako naman tayo sa concrete grade mix ratio. So ito yung table. So makikita natin dito sa first column, yan yung iba't ibang grades ng concrete. Tapos ito yung ratio. Yung first number dyan ay tumutukoy sa bilang ng cement. Yung second column naman tumutukoy sa number ng sand. Tapos sa third column naman ay yung aggregates naman. Tapos makikita natin dito sa right part kung ano yung corresponding compressive strength base dun sa iba't ibang ratio na yon. So meron ditong naka-metric system, tapos meron ding compressive strength na naka-English system. So kung mapapansin natin dito sa table, sa bandang gitna nakalagay na dito na design mix. Wala nang certain ratio. Ang gagawin kasi dito, para ma-achieve mo yung compressive strength na to, ikaw mismo yung magko-compute nung ratio ng cement, sand, tapos aggregates. So, panoorin natin itong video on how to calculate water-cement ratio.
Hey guys, welcome to Civil Mentor. Have you ever been told, or asked to add some more water? The concrete looks very hard. If yes, do you think? Is this right? Adding more water, at the side level to increase the concrete workability? Absolutely, not. But, don't worry. We got your back. Here, we'll discuss everything, related to water-cement ratio. So, let's get started. What is water-cement ratio? Water-cement ratio means the ratio between the weight of water to the weight of cement used in concrete mix. Normally water-cement ratio falls under 0.4 to 0.6 as per IS code 10262, 2009, for nominal mix. Wait a moment, if you don't know about the nominal mix of concrete, then, you need to watch the video. We already discussed about the grades of concrete. The link will be given in the description. We all know that water-cement ratio will directly affect the strength of concrete. Either it will increase the strength, if used in correct proportion, or decrease it. But, have you ever thought about it, why we are using water, if it has so much difficulty? If not, then watch the complete video to understand it. Role of water in concrete. Concrete is a macro content. It contains micro ingredients, such as cement, sand, fine aggregate, and coarse aggregate. In order to acquire a high-strength concrete, which withstands up to our desired compressive strength, we need correct proportion of admixture to combine these materials. Here comes the water which will initiate this chemical process, by adding 23% to 25% of the cement volume. This initiates the chemical process, and makes 15% of water cement paste, also known as a gel, to fill the voids in the concrete. Now, as you know, water initiate the chemical reaction, but, what if we use too much water? Then, what will happen? So, let's talk about it too. Effects of too much water in concrete. As stated above, we need 23% of water to initiate the chemical process on cement. Adding more water than this allowable water cement limit will actually affect the strength of concrete. If we keep on adding water to increase the workability, then the concrete has lots of fluid materials, where the aggregates will settle down and cause segregation. Once the water evaporated, it leaves lots of voids in concrete, which also affect the concrete strength. But, if we follow the guidelines, in order to maintain the strength of the concrete, then it will affect the concrete workability, and make it hard for us to handle and place them. That's why we need to use water moderately. Now, you may think that how to calculate water-cement ratio. So hang on, and let me discuss it too. We don't actually calculate the water-cement ratio. It is selected from various workability tests based on the structural members, concrete strength, transportation, and selection of aggregation, etc. Calculation of water quantity for concrete. As you can see, the water-cement ratio varies from 0.4 to 0.7, depending on the exposure conditions. The formula to calculate the water quantity for concrete is required amount of water equals water-cement ratio multiplied by cement volume. For example, if we assume the required cement volume is 50 kilograms, and water-cement ratio is 0.5, then, the quantity of water will be 0.5 by 50 kilograms equals 25 liters per 50 kilograms cement bag. For design mix, the water-cement ratio will depend upon the workability, strength requirements. Hope that helps you.
So, yun. Sobrang dami nating pwedeng magain na information mula doon sa video na yon. Kagaya na lamang ng kung bakit water yung ginagamit na pang mix doon sa concrete. Tapos, ano yung purpose niya doon. Nalaman din natin na kung papaanong maaaring mapa-strengthen or mapa-weaken ng water yung concrete. Kagaya na lamang ng kapag napasobra yung amount ng water sa concrete, maaari daw itong mag-lead sa segregation ng aggregates. So, sana marami tayong natutunan dito sa report ko na requirements of concrete. To discuss the methods for testing concrete strength, here is Mr. Kim Aaron Familara.
Good day. The next topic is the methods for testing concrete strength. Here, I will present the 7 methods for testing compressive strength of concrete according to ASTM standards. Number 1. Rebound hammer or Schmid hammer. Ito ay under ASTM C805. A spring release mechanism is used to activate a hammer which impacts a plunger to drive into the surface of the concrete. The rebound distance from the hammer to the surface of the concrete is given a value from 10 to 100. This measurement is then correlated to the concrete strength. Sa rebound hammer, may spring sa loob at sinusukat nito yung rebound ng spring pag tumama yung hammer na may certain force sa concrete. Nakadepende yung value ng rebound sa hardness ng concrete at gamit ang conversion chart, madedetermine natin yung compressive strength ng concrete. Number 2. Penetration resistance test. Ito ay under ASTM C803. To complete a penetration resistance test, a device drives a small pin or probe into the surface of the concrete. The force used to penetrate the surface and the depth of the hole is correlated to the strength of the in-place concrete. Sa penetration resistance test naman, may power-actuated gun na may uniform force na ginagamit para i-drive ang probe or alloy steel sa concrete para ma-determine ang compressive strength. Ang concept po dito ay yung lalim ng pagkakabaon ng probe or alloy steel ay depende sa compressive strength nito. Ang kadalasang size ng probe na ginagamit dito ay 6.5 mm diameter at 8 cm length. Ang disadvantage po nito ay low accuracy ang test na ito. Number 3. Ultrasonic pulse velocity. Ito ay under ASTM C597. This technique determines the velocity of a pulse of vibrational energy through a slab. The ease at which this energy makes its way through the slab provides measurements regarding the concrete's elasticity, resistance to deformation or stress, and density. This data is then correlated to the slab's strength. Sa ultrasonic pulse velocity, gumagamit po ng ultrasonic device na nakakonect sa transducers. Yung transducer ay yung nilalagay sa magkabilaang dulo ng concrete at nagsesend ng pulse from sender to receiver. Tapos sinusukat dito yung time interval ng pag-travel ng pulse at dinadetermine yung velocity. Pag higher velocity, ibig sabihin good condition. At pag lower velocity, nag-i-indicate ito na may cracks or voids sa pagitan ng concrete. Number 4. Pull-out test or ASTM C900. The main principle behind this test is to pull the concrete using a metal rod that is cast in place or post-installed in the concrete. The pulled conical shape in combination with the force required to pull the concrete is correlated to compressive strength. Sa pull-out test, minemeasure yung required force na kailangan para mag-pull out yung shape rod na nakabaon sa concrete. Pag matibay ang concrete, mas malaki yung force na kailangan at gamit ang established correlations, madedetermine natin ang strength ng concrete. Number 5. Drilled core or ASTM C42. A core drill is used to extract hardened concrete from the slab. These samples are then compressed in a machine to monitor the strength of the in-situ concrete. Dito naman, nag-extract ng concrete from slab gamit ang drill core, tapos yung sample na nakuha, dadalhin sa lab para i-compress sa machine at ma-determine ang compressive strength. Number 6. Cast-in-place cylinders or ASTM C873. Cylinder molds are placed in the location of the pour. Fresh concrete is poured into these molds which remain in the slab. Once hardened, these specimens are removed and compressed for strength. Sa cast-in-place cylinder, gumagamit ng cylindrical shape na concrete. Bakit nga ba cylindrical shape ang ginagamit? Ito ay dahil ayon sa ASTM, only cylindrical shape sample ang dapat gamitin para ma-evaluate ang quality ng concrete. Nilalagay ang sample sa compression machine at ini-input sa machine ang relevant data katulad ng sample dimension, sample shape, at load rate. Pagkatapos nito ay iraran ang test hanggang sa magkaroon ng failure sa concrete. Pagkatapos ay ire-record ang maximum load at kinakalculate ang compressive strength ng concrete. Last is the wireless maturity sensors or ASTM C1074. This technique is based on the principle that concrete strength is directly related to its hydration temperature history. Wireless sensors are placed within the concrete formwork secured on the rebar before pouring. Temperature data is collected by the sensor and uploaded to any smart device within an app using a wireless connection. This information is used to calculate the compressive strength of the in-situ concrete element based on the maturity equation that is set up in the app. Ang wireless maturity sensor ang tinatawag na future in concrete testing technology. Ginagamit ang test na ito sa ibang bansa at it is proven beneficial in over 4,000 projects worldwide. Sa test na ito, may device na kinakabit sa reinforced bar bago magbuhos ng concrete at may app na downloadable sa smartphone. Pag pumunta tayo sa app, makikita natin lahat ng data na na-record ng device including the minimum at maximum temperature, maturity index at current strength in PSI. Gumagamit ito ng maturity equation para ma-determine ang current strength of concrete. Next nito ay ang video kung paano mag-test ng concrete para ma-determine ang compressive strength nito.
Here's what we need: weighing balance, caliper, gloves, goggles. Take the concrete cylinder specimen out of its moist storage. Use a balance to determine the weight of the specimen. Use a caliper to measure its cylinder diameter. Load the specimen to the calibrated concrete compression machine. Apply load until failure on the specimen occurs. The machine will indicate the amount of compressive force needed to break the specimen. And there you have it. This is how you do the compressive strength test to determine the load concrete can withstand. Don't forget to like, share, and subscribe to PinoyBuilders.ph to get.
That's all for my report, and to present the next topic, here is Miss Alyssa Corin Romanes.
So, yung next topic naman po is yung universal testing machine. So, ano nga po ba yung universal testing machine? So, sabi po rito, a universal testing machine or UTM, also known as universal tester, materials testing machine or materials test frame, is used to test the tensile strength and compressive strength of materials. So, sabi daw po yung universal daw po sa name ng universal testing machine ay it shows po na it can do a lot of tests on materials, components, and structures. So, in other words po, it is very versatile. So, next po, an earlier name for tensile testing machine is a tensometer. So, sabi ko nga po kanina, UTM offers a lot of things. It can be used to assess the strength of materials. It also offers enhanced control and stability during a material testing process. And it also helps ensure accuracy and repeatability. So, para po mas maintindihan pa po natin kung ano yung universal testing machine, here's a video po.
Universal Testing Machine, UTM. Through this lesson, you will be able to identify main parts of universal testing machine that is used to perform tensile test over the materials. A universal testing machine or a UTM is used to test mechanical properties such as tension and compression of a given test specimen by exerting tensile or compressive stresses over the material. These tests are very vital when selecting material for an application. By performing a tensile test, we can measure actual stress strain characteristic of a material by applying a tensile load on the part. As you are seeing in this figure, we will make a specific specimen for the material. When the load is applied over the material, at the beginning it will start necking and eventually it will break over its fracture point. After completing the test, the user can generate the stress and strain curve as we are seeing on this graph. Now let us discuss the important parts of universal testing machine. This diagram represents a common universal testing machine. When the user turns on the testing machine, a hydraulic motor will induce pressure on the cylinder. By using this hydraulic pressure, universal testing machine can impart huge amount of stress over the test specimen. And this can be controlled through instrument panel. UTM can be used to perform compression test as well as tensile test. Based on the requirement, a specially machined specimen will fix on the holder. Hydraulic pressure on the cylinder will gradually increase and hence the stress over the specimen will increase. When specimen subjected to yield stress, it will start to yield. Further increase in stress value will lead to the failure when it reaches fracture point. Strain value during various stages of testing can be manually read from digital length indicator. However, the system can be connected with a computer and automatically generate stress strain graph with the help of exclusive software. By using values from this test and analyzing the graph, the user can easily determine the stress strain relationship of the material. Similarly, the user can find ultimate stress, yield stress, and fracture point of that material.
So, brief history po about the universal testing machine. So, on March 25, 1879, Tinius Olson received patent 213,525 for improvement in testing machine, which patented the universal testing machine. So, nung year 1880 naman daw po, dun po na-invent ni Tinius Olsen yung first ever universal testing machine, and throughout its history, the company has been at the forefront of development and innovation. So, by 1906, Tinius Olsen had 8 different catalogs covering universal testing machinery and instrument, spring testing apparatus and spring machinery, cement and concrete testing machinery, cloth, yam, paper, rubber, and leather testing machinery, wire, chain, and anchor testing machinery, oil testing machinery, transverse testing machinery, and special testing machinery. So, meron po ako ipapakitang video para po mas maintindihan po natin yung history ng universal testing machine.
In the 1850 Esson, various devices for testing materials had been developed, but the goal of a truly universal testing machine proved elusive until 1880, when Philadelphia engineer Tinius Olsen, a Norwegian immigrant who had just lost his job, devised and patented what became known as the Little Giant. Olsen's mechanism was to become the ancestor of all testing machines subsequently produced around the world, while the company Olsen set up to market his invention continues in the testing machine business to this day. This year Tinius Olsen Incorporated celebrates its 125th year of continuous operations. Olsen started attending Sunday Bible classes at the local Lutheran church, where he met the Relas, 2 young brothers who were proprietors of a small-scale making workshop. The brothers asked him to produce engineering drawings for such an instrument, and in his spare time Olsen designed and drew precise plans for the first boilerplate tensile testing machine, with a capacity of 40,000 lbf. The new device, manufactured by the Rela brothers, proved a success, and soon there was a demand for a much larger model. Olsen was invited to take over the workshop, becoming director of the Rela's plant in 1872. In 8 years there he helped establish the firm as a manufacturer of both springs and testing machines. His pioneering contributions to the emerging field of materials testing included vertical and horizontal machines for materials used in bridge construction, locomotive boilers, and other industrial goods. Several of these machines were exhibited at the Philadelphia Centennial Exposition of 1876. The patents remained in the hands of his employers. All this inventiveness did not go unnoticed. In 1879, the Committee on Science and the Arts of the Franklin Institute, Philadelphia's prestigious Center for Scientific Study and Information, appointed a subcommittee to look into Olsen's testing machines. According to the committee's report, the machines were convenient to operate, properly proportioned, and handsomely designed, and accurate withal. Perhaps it was such kudos that prompted Olsen to ask the Relas to make him a partner. They refused, and in late 1879 he was informed that his services would terminate at the end of the year. Olsen was full of ideas for a revolutionary device, a universal testing machine. On February 6, 1880, Olsen submitted an application for a patent, a new and useful improvement in testing machines, and patent number 228,214 was granted on June 1, 1880. In his patent application, Olsen explained that testing machines previously had difficulty the pressure on the sample or wasted most of the applied power in friction. He proposed to build the weighing levers to be more compact, decrease the power absorbed by friction, provide an automatic motion for the weight on the beam, and provide a sensitive measuring apparatus for measuring the distortion of the specimen, as well as an apparatus for graphically recording and illustrating the same distortion.
So, to discuss the next topic, here is Trisha Ann Abweg.
Good day! We are done discussing about what is a universal testing machine and na-discuss na din natin yung history behind it. Now, let's move on to the parts of a universal testing machine. I am Trisha Ann Abweg and I am going to report to you about the loading unit or the host machine of a universal testing machine. From the word itself, loading, ibig sabihin, yung test specimen ay inilalagay natin here sa loading unit. So, sabi nga dito, the arrangement of the test specimen and the exertion of the load takes place in the loading unit or the host machine. Ano ba yung parts niya? So, it includes a load frame, the upper and the lower crosshead, and meron pa tayong elongation scale. So, dito na tayo sa load frame. Yung load frame, it consists of a table, an upper crosshead, and a lower crosshead. So, from this picture, nakikita natin, ito yung load frame. Then, here is the upper crosshead, the lower crosshead, and ito yung ating table. Next, sabi dito, for the compression test, the specimen is placed on the table, and the crossheads are used to clamp ends of the test specimen. Also, dito sa load frame ay meron tayong two sections. The first section sa taas is for tensile testing, and the second section for this section is used for compression test. Next are the upper crosshead and the lower crosshead. So, ginagamit natin itong crossheads for tensile testing. Sabi dito, for tensile test, the ends of the test specimen is clamped on the upper and lower crosshead. So, itong upper crosshead and lower crosshead ay merong jaws to hold the test specimen in place while we are conducting tensile test. The upper crosshead is fixed while the lower crosshead is movable, whose screws can be adjusted for height and can also be tightened. So, since the lower crosshead is in between the upper crosshead and the table, so siya yung nagmo-move. And next is both crossheads have a clamp used to hold the test specimen. So, sinabi ko nga kanina, merong clamp or jaws tong crosshead para i-hold yung test specimen in place while we are conducting tensile test. Last part of the loading unit is the elongation scale. So, the elongation scale is used to measure the relative movement of the table. So, ito siya. Yun lang yung function niya, to measure the relative movement of the table while we are conducting the test. So, here is the diagram of the loading unit. Makikita natin, ito yung upper crosshead, the lower crosshead or the movable crosshead, and here is the table. So, makikita din natin, meron tayong two sections. This one is for tensile testing, and this one is for compressive testing. So, katulad nga ng sabi ko kanina, sa crossheads ay meron tayong jaws. Dito siya nakalagay. That is used to hold the test specimen. And sa table naman, meron siyang plate dito na pinagpapatungan naman ng ating test specimen. Inside here, dito sa part na to, nandyan yung ating mga motors. May iba-iba pa siyang parts dyan sa loob niyan na makikita natin later sa video. And usually, yung elongation scale, andito siya sa may part na to. In between the lower crosshead and the table. So, to further explain the loading unit of the universal testing machine, I'll show you a video.
Hello and good day everyone. I am Engineer Eric Guzman. In this episode, we will talk about one of the civil engineering equipment sa pinakanamitin hindi lang sa school kundi sa iba't ibang material manufacturing industries. Ito ang Universal Testing Machine. A universal testing machine is an electric machine used in engineering where the main mechanical properties of a given specimen of a construction material are being tested. In UTM, we test the mechanical properties like tension, compression, and bending capacity, and some other properties of the materials. The usual process of the UTM is pulling, compressing, bending, or stretching materials until they break. So materials could be metal or non-metal. These different tests determine the quality of the material as well as how suitable it is for a particular use. The universal testing machine is used primarily by laboratories that manufacture or mold various plastics. Additional pointers guys, may iba't ibang tawag tayo sa industry ng UTM. Yung iba, tinatawag nila UTM bilang tensile tester, while others, compression tester and bend tester. Well, some in the industry call it bilang materials testing machine or simply materials test frame. But one common term there is for the UTM is the universal tester. As a laboratory technician or a civil engineer, before operating the UTM or universal testing machine, of course, as you can see, the machine has different parts and those parts have different functions. You should know first what are the parts, the importance of the parts, or how to use and when to use them. So the universal testing machine has two major parts, the host machine and the machine controller. The host machine is a cylinder underneath a hydraulic loading in a hydraulic clamping specimen. This machine operates or functions easily and it reads correctly. The host machine represents where the exact section of the test should be conducted. For the tensile strength test, it should be conducted at the tension section using two flat round grip plates, upper and lower clamps. The tension section is in the upper part of the host machine. The compressive and flexural strength test should be conducted at the compression and flexural section, the lower part of the host machine. For the compressive and flexural test, we use the upper and the lower plate, wear load and bending platform. These are the minor parts of the host machine. The cylinder was fixed on bottom support with bolts. The piston was fixed on work table while work table supports on column. When piston is moving, work table, column, and upper crosshead also moves. The screw crossover work table, down end was fixed on bottom and the up end was connected with up crosshead. There is a remote box or the controller button at the lower crosshead so it is easy to adjust the original test pace and can clamp the upper and lower clamp automatically and column lift upper crosshead to achieve tensile, compression, and bending test. The machine controller is the one that processes the data of materials being tested, storages, and displays the test data. The machine also provides the illustration and graph of the curves using the computer. The printer here can print the test report and draw the test curve of the materials. These are the minor parts of the machine controller. On the left upward side of the control machine, there are two power switches. The bigger one with mushroom head is the emergency stop switch, and the other one is the power switch. The two hand wheels of load and unload are used to control loading and unloading hydraulic oil. Pump is oil pump switch to start and pump motor unit inside the controller cabinet. The button of jaw is tensile grip switch. The tensile grip and remote box will be able to work after pressing jaw button. When clamping samples, take note guys that the upper grip should first clamp and then lower grip will be next. Otherwise, the hydraulic clamps will not work well. When doing tensile test, please turn off the tensile grip button or the jaw button to keep the electrical valve good working more long time. Before using universal testing machines, certain conditions should be observed before to ensure the safety of the operator. Number 1, room temperature at least 10 degrees Celsius to 35 degrees Celsius. Number 2, relative humidity not more than 80%. Number 3, no quaky or vibration condition. Number 4, no caustic medium around. Number 5, level insulation on steady base, level degree no more than 0.2 over 1000. Number 6, finally, we have the power supply. Should be 3-phase 220 volts, 50 to 60 horsepower or 2.5 kilowatts.
So for the short summary, the loading unit is where we arrange and exert the test specimen. It consists of parts including the load frame, the upper and the lower crosshead, and the table. So next is Miss Elena Francesca Mojica will report to you about the control unit of the universal testing machine. Thank you.
For the control unit, the load is supplied and recorded by this unit. It is applied with control valve with the help of a hydraulic pressure and released by a release valve. The three main components of the control unit in a universal testing machine are hydraulic power unit, load measuring unit, and control devices. For number 1, hydraulic power unit. Hydraulic power units, or sometimes referred to as hydraulic power pack, is a self-contained system that generally includes a motor, a fluid reservoir, and a pump. It has an oil pump that provides non-pulsating oil flow into the main cylinder of the load unit. This flow helps in the smooth application of load on the specimen, and also the oil pump in a hydraulic power unit is run by an electric motor. Hydraulic power unit design components include accumulators. These are containers that can be attached to the hydraulic actuators. They collect water from the pumping mechanism and are intended to build and maintain fluid pressure to supplement the motor pumping system. Next is motor pumps. A hydraulic power unit can be equipped with a single motor pump or multiple devices, each with their own accumulator valve. With a multiple pump system, usually only one operates at a time. Next is tanks. The tank is a storage unit designed with enough volume for the fluid in the pipes to drain into it. Likewise, actuator fluid may sometimes need draining into the tank. Next is filters. A filter is typically installed along the top of the tank. It is a self-contained bypass unit with its own motor, pump, and filtering apparatus. It can be used to fill or empty the tank by activating a multidirectional valve. Because they are self-contained, filters can often be replaced while the power unit is functioning. Next is coolers and heaters. As part of the temperature regulation process, an air cooler can be installed near or behind the filter unit to prevent temperatures from rising above operational parameters. Likewise, a heating system, such as an oil-based heater, can be used to elevate temperatures when necessary. Lastly is power unit controllers. The hydraulic controller unit is the operator interface containing power switches, displays, and monitoring features. It is necessary for installing and integrating a power unit into a hydraulic system and can usually be found wired into the power unit. For further understanding, here is a short video about hydraulic power units.
The hydraulic power unit is used by connecting with the electro-hydraulic control in order to control the turbine operation. Even though there are two pumps, only one is used during the operation of the turbine. The hydraulic piston pump is a variable capacity plate type pump, which pumps in order to increase and decrease the volume by going back and forth of the piston at the body of the cylinder. For half of one rotation, piston exits the body of the cylinder in order to increase the volume and inhale, and for the rest of the rotation, discharge working occurs by entering the body to decrease the volume. The hydraulic power unit system can open and close the steam valve by directly sending the fire-resistant oil, which has pressure, to the MSV, CV, CRV, and the trip device. The high-pressure oil which is provided to the valve is collected to the reservoir after going through the cooler.
The second main component of control unit is load measuring unit. This unit has a pendulum dynamometer unit that has a small cylinder with a piston which moves with a non-pulsating oil flow. The pendulum is connected to the piston by a pivot lever. The pivot lever deflects based on the load applied to the specimen, and this deflection is converted to the load pointer and displayed as the load on the dial. The last main component of control unit is control devices. The control devices can be electric or hydraulic. Electric control devices make use of switches to move the crossheads and switch on or off the unit. A hydraulic control device consists of two valves. One is right control valve and the other is left control valve or release valve. A right control valve is used to apply load on the specimen, while the left control valve is used to release the load application. For further understanding, here is a short video about control devices.
A control device is a component used to turn on or off current flow in an electrical circuit. Let's first talk about the limit switch and shift to the others. A limit switch is an electromechanical device that can be used to control machinery as part of a control system, as a safety interlock, or even used to count objects passing by. Because of their reliability, high accuracy, and repeatability, they can practically be used in any industrial setting and are also able to control multiple devices. Most limit switches are composed of three main components. These components are the actuator, the body, and the terminals. The actuator is the part that comes in contact with the target. The body is where you will find the terminals that will be wired. The contacts inside the body can consist of normally open and normally closed and can be either maintained or momentary. In the example, we have displayed the way the limit switch symbols are drawn. They consist of NC, normally closed, NO, normally open, NCHO, normally closed held open, and NOHC, normally open held closed. As of now, you should be familiar with the NC and NO abbreviations and meaning. Let's go over the other two mentioned. The normally closed held open means that the contacts have been wired as normally closed, but something is keeping the switch actuated, which keeps the contacts open. The same concept is used for the normally open held closed. It's been wired as normally open, but something is keeping the switch actuated, which keeps the contacts closed. Both of these contacts will keep their state until the force holding the switch in the activated state is removed. The circuit shows how the limit switch will operate. The PB starts the motor as long as the limit switch is not tripped or actuated. The motor will turn off when the limit switch has been actuated or the stop button is pressed. A temperature switch is a device that monitors temperature and opens or closes a circuit whenever a predetermined temperature is reached. It is used in heating and cooling applications where temperature must stay within certain limits. Most of these switches will contain a NC and NO set of contacts, but can also come with just one of these contacts. In the example provided, when the selector switch is positioned in the auto position, the temperature switch will open and close accordingly to the predetermined set temperature. When the temperature rises above the set value, it will close and turn the motor on. When the temperature drops below the preset value, it will open the contacts and de-energize the motor. Pressure switches are devices used to monitor and control systems that use pressurized fluids. When a certain pressure has been reached, depending on the set value, it will make or break a circuit. In the circuit provided, whenever the switch is closed, the compressor will turn on. After the pressure reaches 60, the first pressure switch will open. Once the compressor has reached a pressure of 105, the compressor will turn off. As long as the switch is on, the compressor will start back after the pressure has fallen below 60. Float switches are devices used to detect the level of a liquid. It can provide automatic control for motors that pump liquid from or into a tank. As the level of liquid rises or falls, it will either close or open a circuit respectively. Due to its reliability, it's one of the most frequently used devices used for monitoring liquid levels. The way it works is utilizing a magnetic reed switch, which consists of two contacts sealed in a glass tube. When a magnet comes close to the two contacts, they become attracted to each other and touch, allowing current to pass. When the magnet moves away, the contacts demagnetize and de-energize the circuit. In the circuit, whenever the float switch reaches a preset low level, the float switch contacts close and activate the motor. The flow switch is the last device being covered. A flow switch is a device used to monitor the flow rate and pressure of things such as air, steam, and liquids through a duct, system, or loop. The circuit provided shows the way a flow switch is drawn and operated. If the flow switch has enough fluid flow to overcome the spring tension on the paddle, then it will close the contacts and turn the pilot light on. There are many different types of flow switches, but the working principle is quite the same. The majority of them have a paddle or magnetic trigger of some sort, which is connected to a circuit and placed through the channel where the substance will be passing through. The paddle is rotated by whatever substance is passing through and sends a signal back to a transducer. The transducer takes the signal and passes it to a transmitter. The transmitter measures this reading against a predefined set of parameters and performs whatever signal or action is required to adjust the behavior of components and mechanisms. That concludes the control devices mentioned in the beginning of the video. Knowing how control devices work and are used will help you in choosing the right control devices for your application.
To discuss the next topic, here is John Christian Arsena. So, good day po. I'm John Christian D. Arsena and I'm here po to present to you the function of UTM. So, recall ko lang bago ako mag-start yung main function ng UTM, which is to test the mechanical properties of a particular material. Then, under UTM, there are standard tests that can be performed under it. So, una na dyan ang tensile test or tensile strength or tension test. Tensile strength of a material is the tension stress at which a material breaks or permanently deforms, changes shape. Toughness, resilience, Poisson's ratio can also be found by the use of this technique. So, bali dito sa tensile test, coming from the word tension, which means the state of being stretched type. Dito, tinetest yung kung gaano yung kayang i-hold ng isang particular material coming from the tension, kung gaano kalakas na yung kaya niyang i-hold bago siya mag-change ng shape o ma-deform. So, para mas maintindihan natin, we have here a video. So, as we've seen in the video, after the tensile test, the gauge length from 1.518 inches, it became 2 inches, which means that the gauge length increases about 35.50%. Then, the maximum load that it can hold became 26,765.5 pounds. Bale, yun yung pinakakayang i-hold ng gauge length na pinakita doon sa video. So, ibig sabihin yun yung ultimate tensile strength na kayang i-hold ng material na yan. So, next one, we have here the compression test. Compression test used to determine a material's behavior under applied crushing loads and are typically conducted by applying compressive pressure to a test specimen. During the test, various properties of the material are calculated and plotted as a stress-strain diagram, which is used to determine qualities such as elastic limit, proportional limit, yield point, yield strength, and etc. Compression testing allows manufacturer to test the integrity and safety of materials and its component. So, bali naman dito sa compression test, as you can see in the picture,
Dito naman parang pinakrush yung isang material para malaman kung gaano ka-elastic yung isang material. Usually, ang mga tinetest dito yung mga plastic, mga foam, ganun. Yung mga example ng mga material na tinetest sa compression stress upang matest yung integrity and safety ng material. So here we have a video again para mas maintindihan natin kung paano nangyayari or paano ang nagiging process sa paggawa sa pag-test ng material using compression test. After the compression test, you can see that the material used there was the rigid cellular plastic. Then, after that, the modulus of elasticity was determined as to be 191.82 pounds square per inch. Then, the stress that it can hold is about 14.13 pounds square per inch. Ibig sabihin, ito yung mga elasticity na kayang i-hold ng cellular plastic na material na pinakita dun sa compression test. Then, itong stress, ito yung maximum na strength na kayang i-hold ng cellular plastic na tinest sa video na pinakita. Then, next one, we have here the adhesion test. Adhesion is the bond strength measurement of a coating to a substrate. When an adhesive is bonded to an item or surface, numerous physical, mechanical, and chemical forces come into play, which may have an effect on each other. These need to be tested before a product can be used. Adhesion testing is often associated with adhesives, tape, sealants, laminates, electronics, cosmetics, medical devices, packaging, general packaging, seal strength, and etc., where bond strength measurement is critical for research and quality control application. So, bali dito sa adhesion test, ito namang test na to, common siya dun sa mga type ng mga material na ginagamitan ng adhesive, tulad ng mga tape, yung mga sealant, lahat ng cosmetic. Yan kasi dito parang tine-test kung gaano kalakas yung bond na kayang i-hold ng isang material. Unlike sa compression test and sa tensile test na ang mga tinetest doon ay kung ano yung kayang i-hold ng material. Dito naman kung ang tinetest ay yung bond na kayang i-hold ng isang material. So, ayun, as we've seen in the video, I hope you understand naman na kung ano yung nangyari. Dito, gumamit sila ng 4 grade types of adhesive, which is from D1 to D4. Yun yung specs nung ginamit na adhesive. Then, after that, para rin lang siyang tensile test kung saan nag-test ng magkadikit na material. Pero dito naman, hindi siya tulad ng mga metal ng mga tinetest. Dito, yung band talaga yung tinetest. Kaya nga, ayun, yung tinest yung kayang i-hold ng adhesive na D1 to D4 bago siya mag-break. Tapos, ayun lang, yun yung kaya niyang i-hold na strength bago siya mag-break. Actually, hindi lang dito na-mention yung load na kaya niyang i-hold, pero yun, parang at least pinakita naman sa atin dito kung paano nangyayari yung adhesion test. So next one, we have here the pull-out test. A pull-out test system having a pull-out apparatus including a plurality of bracing rods connected to a first support plate at proximal end of the plurality of bracing rods and a second base plate connected at a distal end of the plurality of bracing rods. And the pull-out apparatus is configured to be mounted within the UTM via the anchor and the reaction rod to apply tensile forces thereto. So, dito naman sa pull-out test, unlike sa mga naunang test dito, pinaibahan niya, iniipit dito yung isang material sa ilalim, then itatakip ng pinaka-valve. What do you call this? Netong second base plate, iipitin siya nun, then hihilain ng plate sa taas. Kung nakikita nyo dito sa may pinaka picture dito sa gilid, yun yung panghila niya sa taas dito sa may displacement translucent. Then ayun, matetest kung gaano yung kalakas or gaano yung strength ng isang material. Very common dito na tinetest ay yung mga interior ng mga gulong. Yung sa mismong pito, hinihila siya para mas matest kung ano pa yung kailangan i-improve para mas mapatibay yung particular na material na yan. So, para mas maintindihan natin, proceed tayo sa video. So last one, we have here the bending test or the flex or flexural test. It is commonly performed to measure the flexural strength and modulus of all types of materials and products. This test is performed on a universal testing machine with a 3-point or 4-point bend fixture. So ito namang bending test, very common siya. Kasi dito tinetest yung flexural strength ng isang material. Kung gaano siya ka-flexible. Hindi lang to about sa mga metal, kung gaano sila ka-flexible. Kundi sa mga plastic, sa mga foam, kung anong types ng material, tinetest yung flexural strength niya para malaman kung paano mas mai-improve pa sa susunod na mga generation yung mga equipment na ginagamit dito. Then, para mas maintindihan nyo kung paano naman nangyayari itong bending test, we have here another video na ipapresent namin sa inyo. So, here naman sa bending test, next dito ay yung isang type ng plastic with heat which is D790. Dito naman, na-determine na flexural stress at break nito ay umabot sa 26,656 pounds square per inch. Bale, yun yung pinaka stress na kaya niyang i-hold bago siya ma-break. Then, about sa flexural stress, strain at break naman niya ay umabot sa 4.4%. So, ayun lang. Sana naintindihan niyo kung paano naman nag-work yung mga tests under the UTM. Unfortunately, we can perform it face-to-face kasi nga pandemic. But I hope naintindihan niyo naman kahit paano kung paano siya nag-work. Actually, sa UTM, hindi lang siya 5 test, hindi lang tong 5 to. Meron pang ibang klase ng test. Meron din diyang tulad ng hysteresis test which is the magnetic test ng isang equipment. Marami pang iba. Pero ito yung 5 na standard na test na na-perform under UTM, which is very common kahit na ginagamit sa pag-test ng mga material. So, yun lang. Thank you. And to end this presentation, here are the references that you can check and verify. No copyright infringement intended for educational purposes only. So that concludes our report for concrete and universal testing machines. Thank you for listening.